Good morning, and thank you for being here. And Tom, thank you for the opportunity. I will be presenting a two-pager, which you can obtain electronically from Oren, so that you can get everything that I talk about. When I arrived in the States, I asked the Natural Resource Conservation Service to introduce me to the leading conservation ranchers in our neck of the woods in Oklahoma and Texas. And I've been working with them since to find out how they managed to achieve good goals that are aimed at achieving exactly the same things that the Rodale Institute are trying to do, but with grazing animals. So that's what I'm going to be talking about. I'm going to read. I delivered to Congress 5-minute testimony, so I'm going to use the same methodology. I'll read it. To ensure long-term sustainability and ecological resilience of natural resources, agricultural production needs to be guided by policies and regenerative management protocols that support ecologically healthy and resilient crop and grazing agriculture and mitigate anthropogenic greenhouse gas emissions. Although modern technology has substantially elevated most people's well-being and material wealth, the production of food to meet global demand comes at a considerable environmental and social cost. In many areas, instead of increasing food yields, high input agriculture has led to a decrease in food production due to adverse soil impacts. The use of tillage, inorganic fertilizers and biocides have reduced soil surface cover and decimated soil microbial communities, which control 90% of soil ecological function, thereby compromising physical, chemical and biological soil properties. These practices have also led to soil and nutrient losses via erosion, reduced nutrient concentrations in the remaining soil, and reduced nutrient availability to plants, as the Rodale folk pointed out to you. Globally, 1/3 of anthropogenic GHG emissions come from agriculture. Emissions from crop agriculture, as they're currently managed, are the greatest at 24.3%, of which 7.4% is from soil erosion. Emissions from livestock are less at 14.5%, with the beef portion production causing 9.4%. So you can see crops are much the greater element in increasing GHGs than ruminants are, even though everybody's clamoring for a reduction in ruminants. Currently, soil erosion caused by agriculture, as it's currently managed in the US, is 3 times greater than the combined crop yields from corn, soybeans and hay. Extremely unsustainable. And the Rodale folk know how to reverse that. In contrast to the deficiencies of many current tillage-based cropping and feedlot-based livestock production systems, ecologically sensitive, regenerative management of ruminants in crop and grazing agriculture contributes positively to GHG mitigation and other critical ecosystem benefits. Crop production managed to maintain permanent ground cover through the rotation of forage and row crop mixes, cover crops, legumes to increase soil fertility, and combined with grazing livestock can reduce or eliminate the damaging effects of current cropland management, as the Rodale folk pointed out to you. Ruminant production entirely from pastures has been done most effectively, efficiently and economically using appropriate regenerative grazing management. With livestock management focused on building soil health, grazing animals can create carbon negative budgets with more carbon entering the soil than is emitted indirectly or via ruminant emissions. That's a very important aspect. Therefore, erosion and greenhouse gas emissions in agricultural systems can be significantly reduced by replacing erosion hazard cropping systems with permanent pastures under improved grazing management. Producing grass-finished beef also obviates the need for finishing animals on grain-based feeds. This dietary switch reduces the carbon footprint of ruminant production because it eliminates soil GHG emissions resulting from grain production and associated soil erosion. Suitable modification of agricultural production systems and conversion to regenerative, multi-paddock grazing-based, grass-finished livestock increases numerous other critical ecological benefits. On rangelands, which are drier and are not cropped, the use of regenerative, high-density grazing management has been demonstrated globally to be capable of reversing degradation processes associated with a widespread practice of continuous grazing at high stocking rates. The approach involves a single herd, multi-paddock management with short periods of grazing in any given area and proactively adjusting post-grazing forage residuals, recovery periods and other management elements as biophysical conditions change. Done correctly, this increases soil carbon and reverses degradation as bare ground is reduced and plant growth is increased, both increasing carbon sequestration. Data from the Texas tallgrass prairie has recorded an average of 12 tons per acre more carbon sequestered using regenerative grazing compared to the commonly practiced heavy continuous grazing. That is a lot of extra carbon every year. And it jives with all the figures that Chris showed you. Such regenerative grazing has been successfully applied in areas with annual rainfall ranging from 10 inches to 60 inches globally, and I work in many different countries. We are working worldwide with farmers and ranchers that are achieving carbon sequestration at levels that can reverse atmospheric levels of CO2 using regenerative methods. Other studies, mainstream science, have not been able to do so because they do not use regenerative managed methods that I've been mentioning and that they do at the Rodale. So you have to make a distinction between those things. Rather than reducing ruminants and incentivizing destructive high-input agricultural land use through the provision of price subsidies and other supports, developing and rewarding regenerative agricultural practices and policies that focuses on increasing soil carbon and that lead to great adoption by land managers is essential to creating a robust, resilient and regenerative global food production system and will reduce our climate change problem. Thank you.
Thank you, Professor. I'd like to introduce next Andre Loy, the president of the International Federation of Organic Agriculture Movements, also known as iPhone. Andre Loy is chair of the Organic Federation of Australia and is considered one of the leading experts in organic agriculture. He has over 36 years of experience in all areas of organic agriculture, including growing, pest control, weed management, marketing, post-harvest, transport, grower organizations, and developing new crops and education in Australia and in many other countries. Mr. Loy.